We have an equation with a rational exponent. There's going to be a few little twists in this one. For starters, for the first time, we're seeing a 2/3 instead of a 1/3. So there's a numerator other than 1. I'm going to kick this off with PEMDAS, so I do everything in the right order. I'm trying to solve, so I'm doing PEMDAS in reverse. As I look at the left side of the equation, I'm going to start by adding 5 to both sides. That'll give me x to the 2/3 equals 9. There's nothing to multiply or divide on this side, so I've taken care of this. There's none of this to do. To get rid of this exponent, I am going to use a reciprocal power. So I'm going to take both sides to the 3/2, 3/2. On the left side, 2/3 times 3/2 would make 1, effectively canceling that exponent. And now I do want to figure out what 9 to the 3/2 is. So I'm going to first figure out what 9 to the 1/2 is, and I'm going to take that to the third power. 9 to the 1/2, what multiplies by itself? 2 times to give me 9 is 3. Take that to the third, I'll get 27. But because this on this side, on the left side, was an even power that I was getting rid of, I didn't need to include a plus or minus in my answer. My final answer will be plus or minus 27. And the reason for that is because if I were to do all this stuff in reverse, if I were to take negative 27 to the 2/3 power and subtract 5, the first thing I would do is figure out what multiplies by itself 3 times to give me negative 27. And that would be negative 3. Negative 3 times negative 3 is 9. Positive 9 times another negative 3 is negative 27. So the third root of negative 27 is negative 3. But then if I were to square negative 3, I'd get a positive 9 minus 5, of course, which equals 4. So negative 27 works. Similarly, if I were to take a positive 27 to the 2/3 power and subtract 5, I would first figure out what multiplies by itself 3 times to give me positive 27. That'd be positive 3. So it would be positive 3. Then squared minus 5 would be 9 minus 5 again, which is also equal to 4. So the bottom line is anytime your original problem has an even numerator in the exponent, as soon as you get rid of that power, you need to include a plus or minus in your work, because you're going to end up squaring that thing. And when you square it, whether it's negative or positive, it's going to come up being positive either way. Keep that in mind. Look for that. Even numerators, when you get rid of them, you need to include a plus or minus on the answer to the other side. If you remember that, you're golden. Good luck.